Section 9.4. Our objective today is I can apply theorems about chords of a circle. So if I have circle A and I have a chord, remember a chord is a segment whose endpoints are on the circle. So I have chord YX. Then chord YX cuts off two arcs. We have arc YX, which is a minor arc, and we have arc XZY, which is a major arc. Okay. So those are both arcs of chord XY. Okay. And so our first theorem today says in the same circle or congruent circles. Number one, congruent arcs have congruent chords. And number two, congruent chords have congruent arcs. Okay? So in other words, the converse is true. Okay? And so, example, if I have this circle and I have chord P, S, and I have chord T, R, and I have chord R, Q. And I know that arc PT is 50 degrees, and I know that arc TS is 20 degrees, and I know arc SR is 60 degrees, and I know arc RQ is 70 degrees. Okay? Then if length of PS equals 12 and length of TR equals 15, what is the length of QR? Okay, so we want the length of QR. Okay, well, we know that PS, so measure of arc PS is equal to measure of arc PT plus measure of arc TS. Okay, so that gives us 50 plus 20 or 70. Okay, and so then since this arc is congruent to this arc, that means that this chord must be congruent to this chord. And so if PS is 12, that means RQ must be 12 also. Okay? And so we use the fact that congruent chords have congruent arcs, and congruent arcs have congruent chords. Our next theorem says a diameter that is perpendicular to a chord bisects the chord and its arc. Okay, so here's what it's saying. Okay, we have a circle center X, and we have a diameter AB. And we have chord CD. And we know that this is perpendicular, so that we know that CD is perpendicular to XB. Then the theorem says that this point, we'll call it point M, is the midpoint of CD, and therefore this segment is congruent to this segment. So it says if segment AB is perpendicular to segment CD, then segment CM is congruent to segment DM, okay, by definition of bisector. So we know that it bisects the segment, okay. All right, and then our next theorem, okay, our next theorem says in the same circle or congruent circles, the following is true. Number one, chords equally distant from the center or centers are congruent. And the converse is true. Congruent chords are equidistant from the center. Okay, so if this is circle O, and this is A, B, C, D, and this is point X, and this is point Y, okay? And so if this distance is the same as this distance, then segment or chord AB has to be congruent to chord CD, and vice versa. If chord AB is congruent to chord CD, then the distance OX is equal to the distance OY. So they're equidistant. Okay. All right, let's do one example here. Okay. So if I have this circle, circle Q, and I have chord PR, and I know that this is perpendicular to PR, and this is 17. Well, if this is perpendicular, it's actually a part of a diameter, so it's perpendicular to a chord, so that means that this is a midpoint, and so that means PM is congruent to MR. Okay, and I know that this distance is 8, And so then I can find this distance by using Pythagorean theorem. So 8 squared plus, we'll call it x squared, equals 17 squared. Okay? And so we're going to get x equals 15. We finish that. So PM is 15, so MR is 15. So that means PR must have a length of 30. Okay? And a second example is I have this chord and this chord. My center is at 0. And I know this distance is 8 and this distance is 8. And I know that this is 6. Well, this again means that this has to be 6. So that means this whole thing is 12. This distance is 8 and this distance is 8. So this chord must be equal to this chord. So chord, well, I guess I should name it, chord DC also has to have a length of 12.